Inversion of Control, IoC, in Spring. Welcome to this session on inversion of control, also known as IoC, which is one of the fundamental principles of the Spring framework. In this, we'll understand what IoC is, why it's important, and how it's implemented in Spring with practical code examples. Let's dive in. What is inversion of control? Inversion of control is a design principle where the control of object creation and lifecycle is transferred from the programmer to a framework. Traditionally, objects are responsible for instantiating their dependencies. But in IoC, this responsibility is given to the Spring container. This means objects don't create other objects, they are given their dependencies from the outside. This inversion of control makes our code more flexible and decoupled. Benefits of IoC. IoC offers several major advantages. First, it reduces tight coupling between components. This means we can change or replace components more easily. Second, it makes testing easier, especially when using mock dependencies. Third, it improves maintainability and scalability because the application becomes modular. And lastly, it promotes separation of concerns, which is a key aspect of clean architecture. IoC through dependency injection. In Spring, IoC is primarily achieved through dependency injection. There are two main ways to inject dependencies. Constructor injection, where the dependency is passed via the constructor. Setter injection, where a setter method is used to assign the dependency. Both methods let Spring provide required components at runtime. Constructor injection example. Here's a simple example of constructor injection. The car service class needs an engine to work. Instead of creating the engine inside car service, we inject it through the constructor. This means car service doesn't care how or which engine it receives, it just needs an engine object that follows the contract. This promotes loose coupling and improves testability. Setter injection example. This is an example of setter injection. We define a public method setEngine, which accepts the dependency. Spring will call this method and provide an instance of engine when the application runs. Setter injection is especially useful when dependencies are optional or change after construction. Spring annotations for IoC. Spring uses annotations to make IoC simple and declarative. Add component tells Spring that this class should be managed as a bean. Add AutoWired lets Spring know where a dependency should be injected. There are also specific annotations like @service, @repository, and @controller that are specialized types of components for particular roles in an application. These annotations are what enable Spring to automatically wire dependencies without manual configuration. IoC in action with annotations. Let's see how this works with a real annotated Spring class. We have two classes here, engine and car service. Engine is marked with @component, so Spring will manage its lifecycle. In car service, we use @AutoWired to tell Spring to inject the engine dependency. When startCar is called, it will use the injected engine. This simple example shows the power of IoC, no new keyword is needed, and wiring is handled automatically by Spring. To summarize, inversion of control is the foundation of Spring's design. It removes responsibility for object creation from the application code. IoC is implemented using dependency injection, which can be done via constructors or setters. Spring uses powerful annotations like @component and @AutoWired to enable IoC with minimal configuration. With IoC, applications become easier to test, extend, and maintain.